Students, in this short video, I will explain the probability and then the concept of conditional probability. And in the next video, I will cover the Bayes theorem. So, let us first briefly cover what is probability. Probability is nothing but favorable outcomes of an event. If there is any event in which there are certain outcomes which are favorable and divided by total outcomes, then that is defined as a probability. Like the simplest example is throwing of a coin. So, what is the total sample space? Either head will come or tail will come. So, if I define an event that head appears even and another E2 event which says the tail appears, then what is the probability of even? It is nothing but 1, which is a favorable outcome because there is only one chance that head can come and there are total outcomes are 2. So, it is 1 by 2. Similarly, probability of E2 is also 1 by 2. The second example is throwing of a dice. So it can have 6 numbers 1, 2, 3, 4, 5, 6. So what is the probability of occurrence of 1? It will be nothing but 1 by 6. So each number has the probability of occurrence as 1 by 6. Now if I define an event number greater than 3, if I throw a dice and I want a number greater than 3, then in that event I should get 4, 5 and 6. So these are the 3 favorable outcomes and the total outcomes are 6. So probability of this event that I should get a number greater than 3, the probability will be half. You can see here I have drawn this as a Venn diagram. There is an event E2, there is an event E1 which I have already defined here. E1 is a number greater than 3. The number greater than 3 is 4, 5 and 6. You can see here 4, 5 and 6. And E2, I am defining another event, a number greater than or equal to 5 occurs. So 5 and 6 will come in the, I have made a green circle, 5 and 6 will fall in this. So you can see if I define the intersection of E1 into E2, even intersection E2, what I will see that there are two numbers 5 and 6 will come in this. So favorable outcomes will be 2 and total outcomes 6. So probability is 1 by 3. You can see here 5 and 6 number greater than or equal to 5 and 6 5 or equal to 5. So 5 and 6 are the two numbers, whereas in the even 4, 5, 6 are the numbers. So intersection means which are the elements which are common to these two sets. So 5 and 6 are common, that's why I can write, I should write here even intersection E2. If I have to define this set, this will be nothing but 5 and 6. Basis that I can write that probability of even intersection E2 is 2 by 6, which is 1 by 3. Hope you would have understand this basic concept of probability. Hmm? Because probability will always help you to take the judgment in your daily life. Because always you have to have the probability. Thus, if you go to any electronic shop and you buy an item, so you buy an item of a established brand. Why do you buy the item of an established brand? Because the probability of its malfunctioning will be less. So every decision in our daily life is also on the basis of the probability. A student scores good marks in a class means he has more chances of selection. So that is the probability. Even the teachers also guess about the student's quality by his scoring marks in the examination, and basis that they understand and decide that these students has more likelihood or the probability to get selected in any of the competitive exams. So everything what we do here is on the basis of probability. There are so many builders in a metro city. So all the builders they build the flats. So what we go with the established brands and the builders just to take the fact that if we buy the flat from a particular established builder, it's likelihood that the quality of the flat will be good including each item. So everything is based on probability overall. Now we come to the conditional probability. What it says, that if conditional probability is defined as P, it is defined as event even has occurred. So we write it E2 slash even. That is, the event even has occurred. Then what is the probability of occurrence of E2? That is the probability. This is called conditional probability. Means one event has occurred. Then what is the probability of occurrence of the other event? Here, if even has occurred means number greater than 3 I have got, means 4, 5, 6. So what happens that now among the 4, 5, 6, so S1 is the favorable outcome. So these are all becomes the favorable outcome. Out of this, now I have to see E2 has to occur. E2 means number greater than or equal to 5 or 6. So there are only two events, 5 and 6, which will be occurring, which can occur in E2. So after even has occurred, the sample space becomes small, 4, 5 and 6. There are only 3 favorable outcomes, out of which 2 can occur. So favorable outcomes are 5 and 6 in this case. So P of E2 upon E1, if N1 is the total number, it is the total number which are the favorable outcomes. These are the favorable outcomes. I have written here 5 and 6. So 5 and 6 is nothing but even intersection E2. So these are the two numbers which are favorable outcomes, and the total outcomes is N2, which is now given by 4, 5 and 6, which is given by 4, 5 and 6 because sample space is reduced. So N1 upon N divided by N2 upon N, because N is the total outcomes. So if I see it with respect to the original sample space, and if I divide numerator and denominator by n and n, I will get probability of even intersection E2 with respect to the whole sample space divided by probability of even. So I can write here, because I know the probability P of even intersection E2, P1 of even intersection E2 I have already found out, which is 1 by 3 divided by the probability of occurrence of E1, which is 1 by 2. So the total probability, the probability of occurrence of E2 given that E1 has occurred is 2 by 3. You can always understand now your favorable outcomes are 3, your favorable outcomes are 2, and total outcomes are 3. So you can directly write the conditional probability as 2 by 3. So in the conditional probability, what happens? Sample space is reduced. Space is reduced as one event has already occurred. That is, you must remember. I will cover another small and interesting example. Now, if I toss a coin 3 times, if two coins are tossed, then what is the sample space? I have just tried to explain how you can make the sample spaces. If you don't, if you have any confusion, so you can write here by making this table. You can write here HH, HT, PH, and TT. If there are two coins which are tossed, the sample space will be given by this. But if there are three coins which are tossed, then I have tried to establish the sample space H and T, and this is HH I have written here, HT I have written here, TH I have written here. So this is the sample space of two coins, and this is the sample space of one coin. I have made the combination in a tabular form, so I get a sample space if three coins are tossed. If three coins are tossed, you can see there are 8 cases: HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. So you can write, by making a simpler table, you can easily write the total sample space if three coins are tossed. Now, if A is an event that head appears in the first toss, if head appears in the first toss, you can always see head, there are 4 ticks. Hmm, head appears in the first source. So HTH, and HTT and HTT. So there are 4 cases in which the head is appearing in the first. So the probability of occurrence of A, it is 4, and the total sample space is 8. So the head appears in the first toss is favorable outcomes divided by total outcomes, which is 1 by 2. Now head appears in the second toss. Head appears in the second toss. In the second toss, if head has to appear, you can see HHH, HHT, THH, and THT. So in the second toss, if head is appearing, then the sample space will be given by this, and for it also the probability will be 1 by 2, because there are 4 favorable cases and 8 total cases. So probability, now if I have to write probability if A has occurred, means if head has appeared in the first toss, then what is the probability of occurrence of head in the second toss? So this will be given by B by A. So you can see in this case your sample space, because A is first has occurred, so your total sample space gets reduced to this first case. So this will become your favorable cases. This will become your favorable. This will become your total cases. I'm sorry. This will become your total cases. Total chance. And out of this, B has to occur, means head appears in the second task. You can see there is a 1 and 2. I have written two numbers. So in these two cases, head is appearing, head is appearing on the second task. So there are two favorable outcomes. So 1 and 2, they become the favorable outcomes. So your favorable outcomes is 2, total outcomes is 4. So conditional probability is 1 by 2. Okay. Now, if you can see, if I do PA intersection B, I try to explain it with the help of the formula. If PA intersection B, PA intersection B, you will see HH here, HH here, and HHT here, HHT here. So, PA intersection B is nothing but 2 by 8, which is 1 by 4. This probability is with respect to the total sample space. So probability of B by A is nothing but P of A intersection B divided by P of A, which is 1 by 4 divided by 1 by 2. So 1 by 4 into 2 is 1 by 2 is what I have directly seen. So hope you would have understood the conditional probability. You must remember the fact that if one event has occurred, then sample space is reduced and the occurrence and the probability of occurrence of another event is calculated with respect to the reduced sample space. So this is called conditional probability. So hope you can now solve more examples on conditional probability. You can write to me with your problems and I will give you the answer through the video. Thank you.